Today what we're planning on covering is I made a practice quiz for you guys on Canvas, and if you were here for the last one, basically what we did is I had questions and I wrote A, B, and C next to them, and then you guys would give me an answer and we'd discuss why the answer was the way it was. Then we'll go into the additional math functions that are in the C math library, and then we'll do 2 practice programs with those, one that calculates quadratic roots and the other one for a continuous compounding calculator. And then I also made some practice questions on Canvas if you did want extra practice. All right, so starting off with our practice quiz, this is available on the SI Canvas page, so you could follow along with me if you'd like, or you can just type the answers in chat or both. So I'm going to go ahead and go over to modules. This quiz is ungraded as usual, completely optional. Under week 3, I have this one, debugging input and arithmetic. So let's go ahead and start that. All right, so question 1, a programmer found an error and they compile their code. And this is the warning that they got back. What line do you think the error is on? And this is practice for your exams and also to check understanding. So here, I'll mark these, A, B, C, and D. And you can type this in chat, private message, or say it out loud. Any way works. All right. If you don't know, that is okay. That's why we're here, to get anything clarified. So C++ errors are written in a very specific way. We have this first part right here, which is actually one of the very most important parts of the error. The first part tells you code.cpp, that's what file the error came from. Then we have those 2 numbers, the 9 and the 7, which are really useful actually. So the 9 refers to the line number that the program or that your compiler got confused. And then the 7 refers to the actual character number. So the character in that line where it had an issue. So we know that this is going to be one of the 2 with the 9, but which one? Well, remember that our code is going down the lines in sequential order. So we have like line 1, and then we have line 2 and line 3, etc. At the moment, we're going through these lines in sequential order. So first we're going to look at 1, then 2, and 3, and so forth. So if your compiler found an error on line 9, well, the error has to be either on line 9 or above because it hasn't seen any of the code below line 9 yet. The code below line 9 doesn't exist to it. So either it got confused on one of these lines above and then finally realized, oh wait, that's actually a problem when it got to line 9, or the more common answer is the problem is on line 9. So your answer for a question that looks like this on an exam is the line number, which is right here, or above. And feel free to interrupt me if you have any questions. All right. Programmer wrote the code below. It didn't work as intended, but they received no errors when compiling. What type of error is this? That would be correct. It is a logic error. Logic errors are errors that are not detected by the compiler. So syntactically, there's nothing wrong with your program. The computer sees this code and it says, oh yeah, that looks great. I don't care that it says A minus B when we wrote sum over here. It doesn't care about that. It just sees code that looks great to it, and it's going to do exactly as you tell it. However, it obviously didn't do what we wanted. So this is a logic error. All right. What is the value stored in result after executing the line below? And Steve does like putting questions similar to this on exams, so good to get some practice with them. All right, one person says D and another one says B. So let's take a look at this. So the computer is going to evaluate this expression the same way that we would in math, as in terms of what comes first. So if you guys remember PEMDAS from a very long time ago, that's going to apply here too. So first we're going to do the parentheses. So let's rewrite our equation. 9 divided by 2 plus 7 times, well, the result of what's in the parentheses would be a -1. All right, then the next thing that we do is we're going to see this 9 divided by 2. Well, the thing to note here is these are integers, 9 and 2. So if we were to go on a calculator and do 9 divided by 2, you'd get 4.5. However, since this is integer division, the remaining decimal point on the end of the 4.5 is truncated. So this results in 4 plus 7 times -1. All right, so now we're going to do the 7 times -1 part. So it's going to be 4 minus 7, and the result is -3. So -3 would be your correct answer here. And it's all because of this integer division. So be careful when you see this. If it's 2 integers on either side of the operator, it's going to perform integer division. If we had 9.0, then that would result in a 4.5, and then you could do the rest of the equation. All right, any questions on that? Alrighty. Next up, feel free to stop me if anything doesn't make sense. All right, what is the value of result after this one? All right, one person says 2. So remember, this is the modulus operator. What it does is basically the opposite of integer division. So integer division will get you the result of that integer division, and modulus gets you the remainder. So a good way to do these type of questions is actually to go back to long division. So what you're going to do is you're going to pretend that it's 10 divided by 4. And then 4 goes into 10 twice with 8. And then we do 10 minus 8, and we're given a remainder of 2. This is going to be your answer. It is the remainder. This is not a percent. This is not floating point division. This is the remainder of whatever your expression is. And it's actually a very useful operator, which you'll see in the future. All right, very nice job. Okay, which of the following are ways to avoid bugs in your programs? A, B, C, and D, and yes, there we go. Yes, the correct answer is D. All of these are very good programming practices. The more you practice, the less mistakes you'll make, so that's always good. Compiling frequently is very, very, very important, especially when you're new to programming. Actually, I'm going to take that back. Anytime you're programming, compiling frequently is very important. That way, when you find bugs in your program, it's easy to address where they came from. Because if you know, oh, I compiled all these lines of code a few minutes ago, and I just added like 5 new lines, and I have errors now, the errors had to come through those new lines. And then when you get an error, be sure to address it because it's not going to disappear. Alrighty, good job. Next one, I think we have like 3 questions left. What is the output of the following program when the input is San Francisco? So just to clarify, if we had the terminal over here, when we get this enter your city of residence prompt, the user entered San Francisco. All right, it looks like that's probably an answer for D, I'm going to assume. All right, so the correct answer, this is a tricky one. Yeah, but then you got it. The correct answer is, in fact, B. And this is because the CN stream right here will take characters until it sees white space. So basically, it's going to see the S, and it says, oh yeah, it's a good character. It's a letter, not white space. It's going to see the A, it's going to input that, the N, it's going to input that. Then when it reaches this space, it sees the problem. Because how CN is defined is to keep taking characters from input until it finds white space. And white space is going to be spaces, it's going to be tabs, and it's going to be new line characters, which is the same thing as typing enter or return on your keyboard. So what's going to happen is it's going to take this word San. When it sees the white space, it stops, takes San, it inserts it into the variable city, and then this Francisco part kind of just gets left there. You'll learn exactly what happens to it later, but for now, just assume it gets just left there. So San is getting stored in city, and then you live in San is going to be the result of this. All right, so very nice catch. How could the programmer have fixed this code, so just the CN statement, so that it would have gotten the entire city name, San Francisco? So with the space. And this is a typing question, and it's kind of difficult because I can't show you guys both questions at once. Hopefully this is okay with this. Yeah, exactly. It is get something, and it is formally called get line. So, yep, perfect. Yeah, Emily, that's exactly it. So it's going to be get line. And the first thing that you put in the parentheses is the stream that you're using, which is CN, a comma, followed by the variable that we want to store a value in, which is city. And ending with a semicolon, this would be the correct way to fix the problem above. All right, very nice job. And this is second to last question here. So this is a busy one, but it is helpful to be able to follow this type of stuff. What is the ending values of variable 1, variable 2, and variable 3 after executing all of this? And I'll give you guys around a minute to do this one. All right, let's try that out. I'll put 8, 2, 2, and let's follow this from the beginning. All right, so I'm going to, this is good tips for your test too. Var 1, and I'll make a tally, var 2, and var 3, because you will be allowed to have paper. And your tests aren't for a while, so don't worry, but I'm just prepping you guys in advance. Okay, so they all start off with whatever value they're initially assigned. So var 1 is 0, var 2 is 2, and var 3 is -3. Then we move on to this line where variable 1 is reassigned to the value of variable 2 plus variable 3. So the value of variable 2 plus the value of variable 3 would be -1. So put that there. All right, so now variable 3 is assigned with whatever's in variable 1. So now we go over here and look at what's in variable 1, which is -1. Remember, when we reassign a value, anything that was there previously is completely erased. We can never get that 0 back. So it's just holding the -1 at the moment. So we'll put this here, -1. And then we have just done that line. We've done that line. Wait, we haven't done that line. Next, we're going to variable 1 is assigned with variable 2. So variable 1 is assigned with 2. All right, variable 2 is assigned with what was in variable 1. So this is 2 again. And finally, variable 1 is 8, and variable 3 is variable 2. So you got it absolutely correct. Very nice job. So the correct answer is 8, 2, and 2. So great work. All right, any questions on that? And welcome to anyone who joined. We're just finishing up this practice quiz, which is available in Canvas. If you did want to take it later, we are on the last question here. So this one is we are filling in the blanks to output any double in our program, actually any number in our program, to 3 decimal places. And I want you guys to assume that IOMANIP has been included. So what is this going to look like? Let's start off with what goes in the first box. Yes, that would be correct. Cout, because this is formatting output, so it's a part of your cout statement. All right, what about here? That would be correct, fixed. Fixed just means that your numbers, when they output, they're going to not be in scientific notation. All right, and this box right here, precision, yes, set precision. I can spell. I think I can spell. Actually, no, I'm gonna just take it from chat. I'm not going to mess with this. All right, and the correct answer that goes in the parentheses is 3. Whatever we put in the parentheses is how many decimal points we are going to get in our program. All right, very nice job. So I'm going to submit this and verify. Oh, I clicked the wrong one. My bad. We talked about this. We talked about why it's not this one. I clicked the wrong one. I'm very sorry. Well, you guys know that it was line 9 and above. All right, cool. Everything but that first one where I clicked the wrong button came back all right. So does anyone have any questions on anything that we covered in this quiz before we move on to our math stuff? All righty. If not, we are going to go look at some more math. I know everyone's favorite, but at least we get to see some more cool stuff. All right, so recently we learned about some new math functions that we can have in our programs, and we get those math functions by including another library, and this one is called CMath. In order to use like the power of and the square root function, all of those need to be, we used the CMath to get those. So we put another include CMath at the top of our program. And all of your include statements should be the very first thing in your program. They don't go like right before you're going to use your function or anything like that. You include them one time and they always should be the very first lines of your code. All right, so now let's talk about the three important functions that you are going to need to know for this class. The other ones, there are quite a few, but they're just extra information. But the ones that you will actually be using frequently are these three right here. So the first one to know is POW, which stands for the power of. And what this does is you give it two numbers, a base and a power. So as described, base is going to be raised to whatever power we have. So if I did POW 2 to the power of 3, this is going to be the same thing as 2 to the 3, which is going to be 8. That's how POW works. Square roots, whatever we put in the parenthesis, we're going to just get the square root of that. So that those two are equivalent. So if we did square roots of 4, this is the exact same thing as saying square root of 4, which we know is 2. And the very last one is fabs, which is for absolute value. This is the same thing as saying absolute value of num. And to demonstrate this, if we did fabs of -1, this is the same thing as saying the absolute value of -1, which is 1. So let's take a look at those in the program very quickly, and then we will get to actually using them in better application. So I did want to show you guys one new thing also. We can create multiple variables of the same type like this. So what I've effectively done is created 3 double variables without assigning them any value. And as long as I put commas in between them, this is completely fine. This is the exact same thing as saying double power and double absolute val, but it's just less lines. So thought I'd show you guys that. All right, so now we're going to look at how. So I'll assign power, just a variable, because I'm going to print that out down here. And I'll use pow, and then 2 variables that I have here, we'll just do 4 to the power of 3. So remember, this is the exact same thing as saying 4 raised to the 3rd power. All right, so let's do, wait, I wanted to actually use the variables for this. That is why I have them. And B, there we go. How would I do the square root of 4 if anyone wants to type it in chat? Actually, the square root of, yeah, but use the variable.
Would it be the SQRT and then parenthesis 3?
Like this?
Yes. I
Yeah.
think. Okay.
That would work if we wanted to do the square root of 3. And you know what? Let's keep it there because it does work. All right. And lastly, I'm going to find the absolute value of -3. So I'll just use my variable C for that. So that is fabs. And then whatever variable I want the absolute value of, I put inside the parentheses. So this is the exact same thing as saying the absolute value of C, which we can see in our variables is -3. So it's the same thing as saying absolute value of -3 is going to get stored in the variable absolute value. So now let's go ahead and run this just so you guys can see that it works. And I will clear some of my messy drawings over here. So I'm going to do G++, this is math functions. All right, no errors and warnings, so that's great. 8 it out. Okay, what the heck just happened here? Give me a second. All right, so I am recording this in post because we ended up getting a very, very weird, not even an error because the compiler didn't pick up on it, just an issue that happened with the program when we did the square root of the integer literal 3. So I told you guys that I would look it up and see what is going on there. I did look it up and I could not find anything about it. So I ended up asking Steve, and it confused Steve just as much as it confused me. But he presumes that it could have been A, something with memory not working properly, or B, the variables weren't assigned values as soon as they were declared on that initial declaration where we say double square root, double power, like all that stuff. We didn't initially give them a value, so it could have been that, although that shouldn't cause this issue. Or finally, CMath wasn't linked up properly internally, but it turns out that square root of the integer 3 does work. I tried it out later that night that we were talking about this, and I reran the same program and everything worked just fine. So in general, yes, you should be able to use integer literals with these functions with no problems. It was just a very random, weird case that we came across that was not the program's fault. No, everything we wrote was fine, but just internally something went wrong. All right, so the more you know. Any questions on this before we go ahead and use these?
So what you just figured out just kind of like reminded me of like what we did in class when he was talking about like I think I had asked the question, what is doubles? And then anyways, when he asked the question, what would make more sense? I don't think he said exactly like this, but he had like how you have it like A equals 4, B equals 3. And so he's like, you could use A or you could use the number like you said, but as long as you have the decimals. Anyways, it just
Yeah.
kind of reiterated what he had said, but it reminded me of what he was talking about in class. So anyways.
Yeah, awesome. I am honestly going to have to look this up because I did not expect to see that error, especially because these are ints at the moment. So it's fine with the int and the variable, but it's not fine with it literally as an int. So I will look this up, and next SI session, I will tell you guys what the heck happened here. New things to know. Alrighty, so next we are going to learn from that error and go ahead and look at the next program activity that I have for you guys. So this is to create a quadratic formula calculator. So you probably remember your quadratic formula, and if not, it is written right here. So it's negative b plus or minus the square root of b squared minus 4ac over 2a. So we are going to take this formula and translate it into code in which we get inputs for 3 numbers, and then we're going to output the roots of this. So remember, the roots of a quadratic are where it's intercepting the x-axis. So we're going to use this formula right here to figure out where that is. So let's take a look at what we have here. So we're going to use an input prompt for them to enter some values. So how am I going to do that?
Are we going to use the variables A, B, and C? I don't know if
yeah, that sounds great.
Okay.
So we'll use these variables that I have up here. I just defined them in that other way where it's the same thing as saying double A, double B, double C, double X1, double X2, just a more concise way of writing it. So we didn't take up a million lines, but either way is completely fine. So use whichever one you're more comfortable with. But yes, these are the variables that we're going to be using. So we want to prompt the user to enter values. So we need to tell the user, hey, I need you to enter something for A. So we do that using a cout statement. So it's just a cout statement, and then we say enter a number or A. And these usually do not have an end line at the end of them. All right, so now we're going to take input for A. So how do I do that?
So A here represents 1. I don't know.
You're all good, no worries. So someone private messaged me that we're going to use the CN stream, and you're absolutely correct. Whenever we are taking input, so remember input is the user is typing something over here on their terminal, and we want to take whatever they type and store it in a variable so we can use it for later. So right now we're seeing numbers right here. There's no text with like spaces in between, so we're probably going to want to use just CN rather than getLine. So CN is perfect. So we say the CN stream, which fun fact stands for characters in, and cout stands for characters out. So we're going to say characters in, and wherever we want to put the characters that we've just inputted. So if we're taking input for A, we'll store it in the variable A, and then just ending of a semicolon. All right, so I'm going to spare you guys watching me type for the next 5 hours. So I have gone ahead and written the next 2 input statements. So these are just by the same syntax where we did cout, enter a number, and then input for that number. Cout, enter a number, and then input for that number. So it's always prompt, input, input. And now I think is a good time to compile my code to make sure that it works as I expected. So I'm going to do G++, and I have this named as quadratic.cpp, and running the executable. So it prompted me to enter a number for A. I enter 1. So what the CN stream saw is I typed 1, and then I hit the enter button on my keyboard, or it's also return, which is the same thing as a new line character. So CN saw that new line character, which is considered white space. So that means that it said, okay, I'm going to stop now. So it took the 1, it stored it in A, and then it's done. So now we move on to the next line, which is cout, enter number for B. That printed, and now it's here waiting. And it's going to keep waiting until we enter the line. So it's going to wait for B. B is -5. And I enter. So that's white space. So CN says, okay, my job is done. So now we hit the cout statement, enter a number for C. And now CN is waiting for us to enter something. And this is more issues, but I do know where this one is coming from. This one is coming from the fact that x1 and x2 are not assigned with any value when I created them, right? So basically, not so randomly, but for our purposes, randomly, it's picking a value to assign to our variable. It doesn't really have any significance, but variables are always holding a value no matter what. It's no such thing as an empty variable. So you create them, your compiler is going to randomly choose something to put in here. And mine just happened to choose this and this, which is why we do usually have to assign our variables a value upon declaring them, or later in our program, we can take input for them or assign x1 and x2 with values, which I have as a note right here. But that's what happens when you don't do that. So that is where that error is coming from. That's not really an error. All right. So now it is time to actually execute our quadratic formula over here. So the operators that you guys have learned so far in C++ are plus, minus, divide, modulo, and multiply, along with the new ones, which aren't actually operators, they're called functions, but they allow us to do some more mathy stuff. And using a combination of all of this, we need to rewrite this formula in a coding format. So, what do you guys think I might want to do? This is a long formula, but we're going to get through it. Yes, exactly. We need to include CMath. And we need this because we can see in our equation, we have a power of, and we have a square roots. So yes, CMath is important. Thank you very much. All right, put x x1 and x2 as the quadratic equation. Yes. So the reason why I have two different variables here is in our original quadratic equation, we have this plus or minus operator, which is not a thing. So we're going to need one equation where we use plus and one equation where we use minus. So, so this would be x1, x2. And the good news is it actually translates pretty well. So we're going to say x1 equals, and then it's going to be this huge equation over here, and one of which we'll choose to be minus and one of which we'll choose to be plus. So we'll have x2 is assigned with. All right, so one thing that might help you guys out here is if I were to write this equation all on one line rather than as a fraction. So this is the same thing as saying negative b, I'm going to just go with plus the square root of b squared minus 4ac in parentheses divided by 2a. All right, now it's all on one line, which is going to help us a little bit with programming this. So I'm going to just go down this line and write it as code. So remember, parentheses, they're a thing in C++. Parentheses are going to just change the order of operations just like they do in math. So first thing I see is negative b. Well, that's negative b. And then a plus. Now, how would I write the square root of some value? And if you want to actually try writing this value, go ahead.
Would we use the SQRT parentheses?
SQRT parentheses. All right, so whatever we put in the parentheses is going under the square root symbol. This is the exact same thing as writing a square root symbol. And whatever is in the parentheses is this thing right here. So we want to find the square root of b minus 4ac. So now we need to find b to the power of 2. So how might I want to do that?
Pow 2 or
Yeah, you got it. And Andre, you got it in chat too. It is pow, b is your base, and 2 is your power. So this is the same thing as saying b raised to the power of 2. Those two things are equivalents. All right, very nice. So now we have this part's done, this part's done. We have our square root symbol. We just did b to the power of 2. So now I'm going to just separate this so we can see a little bit more what's going with what. So we're still inside of our square root parentheses, which are this one and this one. So we're still under the root. So now we're going to need to do minus 4 times, and in C++, remember, we can't just do 4ac, right? That does not work. We have to have the star symbol between each of our operands. All right, so that takes care of everything under the radical sign, right? We say the square root, which is the exact same thing as writing this. That's identical. Then we say pow, b to the power of 2. So this is b raised to the second power minus 4ac. Those two are identical. Look at that. Awesome. All right, so that takes care of everything under, nope, that's not what I wanted to do. That's not it either. The formula, there we go. Sorry about that. And very nice. So now we have the numerator done. Now we just need the denominator. All right, so denominator, we need to make sure we're outside of this parenthesis because this one is connecting over here. And then we have this one connecting here. And then finally, this one is enclosing the stuff for pow. So good thing to keep track of those parentheses. And now we're going to do more parentheses. We want to make sure that 2a gets evaluated before we divide this whole thing. So now 2 times a. What do we think about that? That makes sense?
It does. When it got to 2A, I was like overthinking it. I thought it was gonna be something more difficult than that.
No, you're all good. It's easy to overthink this stuff, especially when it's such a convoluted equation like this one. But the trick is to take your equation and see if you can write it all on one line just as a math equation. Because if you can write your equation on one line just as the math itself, that's going to help you a lot with converting it into code. And then from there, just go character by character in your math equation. We saw, okay, the first thing is negative b. We write that. Then we do the square root. And the only thing to remember with these functions is just whatever goes in your parentheses is the thing that's being, you're taking the square root of. All right, so now I'm going to just take the exact same equation and use a minus symbol just so we get both potential answers, the negative and the positive. And now I'm going to run that and we're going to see how that goes. Hopefully it goes well. All right, no errors, so that's a good sign. Enter number for A. I need to move the chat so I can see what I wrote here. 1, -5, and 6. Please work, please work. There it is. All right. X is either 3 or 2. And the previous to you, I have Desmos up here. This is the exact same equation that we just wrote. I just have it in the standard form. And then when I zoom in on the graph, we have a 0 at 2 and a 0 at 3. So this calculator will work when your zeros are non-imaginary. So yeah, that's kind of cool. Any questions on this? All right, hopefully that all makes sense and great work. So that is it for the quadratic calculator. Let's see. If we get not a number, yes, that means that it would be no real zeros. So on a graph, you would have no x-intercept, but we know, well, if you're in that math, that you can have imaginary zeros. Doesn't work if you only input positive numbers. Well, it depends on the equation. So depending on what I do to this equation, look, now I have no zeros. So if I were to input these numbers, it would give me not a number. Here, let me run this again. Okay, so I had 1, I had -5, and I had 7. Not a number or not a number. It just means that we're not intercepting the x-axis, so therefore there's no zeros. Let me see if I can get one that has positive numbers. Plus x plus 2. Nope, that's too high up. Shoot. I am not good at this. Oh, there we go. Here's one with all positive numbers that I think has 2 zeros. Yes. All right. So when I entered this into my equation, so A is 1, B is 3, and C is 1. If I can bring back C. Let's try this. A is 1, B is 3, C is 1. Okay. So yes, it has zeros. They're not nice, pretty numbers, but yes, they do have zeros. And then if you had just 1 0, I'm planning on actually having you guys revise this calculator where when it has not a number, it will actually say there are no real zeros. So we'll get into that next week. So yeah, hopefully that answers your question. All right. So we have one more example program for today. And this is compounding continuous interest. So there is this formula, which basically is if continuously you're compounding the interest of some statement, this is the formula for that. So we have E, we have to a power of, so we're going to be using some of our math symbols. If you don't know what this formula is, don't worry about it. I think you get it in math 4. So this is your formula. If you don't know what it means, don't worry. We're gonna just say that these are all numbers, which they are. So I already have your input statements here because all we're focusing on is just the calculation. So I'm gonna just compile this really quick so you guys can see what it looks like right now. Compounding.cpp, 8 outs. It says enter a principal. So principal is this thing right here. It's your original amount. So I just have on your example 4,500, and then enter amount for R, 3.2, and enter amount for time. So this is again the garbage value because the value for P is not assigned, and that is our job. So I will put P here is assigned with, and then we are going to execute this formula. So E is one of the functions that I have not told you guys about yet. And these are available in CMath as well. It's just you don't use them as frequently. Here are just a few of the many things that are available in CMath. So I have a chart for you guys if you ever want to get some more math functions. Here are some of them along with what they do and examples. So the one that we're going to be looking at right now is X right here, which is just E to any power. So that one's going to be useful in this equation. And now I think you guys have all the information you need to know to write this. So what is the formula going to be? What do we think? Oh, wait, I need to bring my formula back, huh? That would be useful. Oh, and this P sub 0 is the same thing as P naught right here. Wait, no, that doesn't clarify anything. This is the same thing as P0. So we do have all of our equation on one line. So basically it would make sense just to go down this equation and type in those numbers. So the first number that I see is P naught. And then that's times, there's an implicit multiplication here, which works in math, does not work in C++. So we put in our star, and then E, let's look at our function table right here, E to a power. So this is EXP, wait, and then parentheses. So this is the exact same thing as writing E, and then whatever's in your parentheses goes in this box. So EXP parentheses value is the same thing as E2 value. So in my parentheses, I'm going to just multiply R and T and save that. And I'm going to run this again. Just making sure everything is working. Oh, I see it. I did not include CMath. And this is what happens when you don't include CMath. I get very confused. So yes, if we need to use these, including CMath is a good idea. All right. So one more thing, rate is a percent. So we divide rate by 100. I think. Let's try this again. Okay, that looks good. 8 out. Let's see, our principal is 4,500. 2, 3, and there it is. After 3 years of continuous compounding under 3.2 interest, you would have whatever you have in your bank, this number would reach this value. If it is continuous compounding, this is your interest rate, and this is your time. That's basically what this formula is good for. I just needed another example of using these functions. So any questions on this one besides my obvious mistake right here? Alrighty. So so that is this one, and that is actually all I have for today, but we don't have enough time for them. But I added to the Canvas page some more practice problems with CMath if you wanted to give some a try on your own. So I have some instructions here. This is your output of what you should get. And then I have starter code if you don't want to write all the way from scratch. Just something to get you started with, if it ever loads. Show in Finder. So there's code to get started with, and it just has a bunch of comments of what you should do. And then I also have the answers to these problems here. These, of course, are not mandatory, but I know some people were asking for extra practice. So here is that. Actually, you know what? We do have time for this one. We have time. I'm going to open in Finder, and we're going to try, because this one's only one line of code, BB edit. All right, so here is one of those practice problems that I gave you guys, and I'm going to take the instructions and move them over to my desktop. I didn't think we'd have time for this, otherwise I would have had it set up. I'm very sorry. Okay. Moving stuff around. There we go. All right, we are all set. So your instructions are using the starter code that I provided to assign C with the value of a squared plus b squared. So we're writing our formula here. How am I going to write it? All right. Yes, that looks great. So we have C is assigned with the value of a times a plus b times b. We could also do, if you want another version, square root of how base would be a exponent 2 plus how base would be a exponent 2, b. Base would be b exponent 2. These lines are both equivalent. It doesn't matter which one you use. Either of them are fine. Honestly, Emily, your version is probably better just because it's so much simpler and yes, it is much simpler, less code, easier to read. But if we had, for whatever reason, to the 10th, then you'd probably want to use POW because it's just too many multiplications. And I'm almost there. Codes. And today is the 15th. Okay, there we go. Yay. And now we can actually run this code. So G++ and Pythagorean. And I should actually remove this. A, so we'll have side A is 10, side B of your triangle is 12. That means that your hypotenuse is 15.56. So this is the calculations for when you have a right triangle. That is not a right triangle. I did have a right triangle. And we had, this one was 10, this one was 12. The length of your hypotenuse is the 15.6205. All right, very nice work. Okay, so sorry about all the extra chaos. I am still sick, so I'm going to blame it on that. Any extra questions before we wrap up for today?
I had a question, but not about this.
Yeah, for sure.
For the labs, we just turn those in as like CPP files, right?
Not quite. So
Oh.
for your labs, wait, no. The assignments are the labs.
The labs.
Like the ones from in class?
Yeah.
Yes, actually, yes. Those are
Okay.
just the CPP files for the assignments that you'll have, and that's when you'll have like assignment number 0 on Canvas. So it'll have like 100 points attached to it or something. Those ones are the zipped up file of just your CPP file, no A.out, no screenshot. It's just your CPP file. but it has to be in the zip file. But just for your labs in class, yes, those are just the CPP. All right, any other questions? Zybooks, programming, labs? All right. Well, that is all I have planned for today, and we are just about at 3 o'clock. So I am going to stop the recording